Tonight, we're asking one of the deepest questions anyone has ever dared to ask. What was there before space itself existed? Before the first stars, before the first atoms, before even time had a chance to begin? If space is everything that has ever contained anything, what could possibly exist before it? It's a question that seems almost impossible to picture. After all, every thought you've ever had has happened somewhere. Every moment of your life has unfolded inside space, carried forward by time. But what if both of those things had a beginning? And if they did, what was waiting on the other side? Before we begin our journey, if you enjoy these relaxing explorations of science, space, and the universe, I'd really appreciate it if you left a like and subscribe to the channel. And let me know in the comments where you're listening from, and what time it is where you are. It's always fascinating to see people from all over the world gathering to wonder about the cosmos together. Now let the room grow a little quieter. Settle into a comfortable position and allow your body to relax. There is nothing you need to remember tonight and nothing you need to solve. Simply let your imagination drift wherever these ideas gently carry it. Together we'll travel to a place that may not even be a place at all, to the mysterious boundary where space, time, and perhaps reality itself first came into existence. Imagine for just a moment that you could travel farther than anyone ever has. Not simply beyond the Earth or beyond the Moon, or even beyond the billions of stars that fill our own galaxy. Imagine drifting beyond every galaxy that has ever existed. Past every cluster of galaxies, every cloud of gas, every lonely black hole quietly wandering through the darkness. You continue farther still. The universe around you slowly begins to thin. Galaxies become tiny islands of light scattered across an endless ocean of black. Even those distant lights begin to fade until there is almost nothing left to see. Eventually, you reach a place where your imagination begins to hesitate. You wonder if you've arrived at the edge of everything. But then another question quietly appears. What lies beyond that edge? It's one of the most natural questions a curious mind can ask. Whenever you come to the end of something, a road, a forest, a coastline, there is usually something waiting on the other side. Perhaps another road, another forest, another shore. Your entire life has taught you that every ending has another beginning beyond it. So it feels perfectly reasonable to ask whether the universe works the same way. If space stretches in every direction, could there be something beyond it? And if the universe had a beginning, what came before? Tonight, it's that second question we'll gently explore. What was there before space itself existed? At first, the question seems wonderfully simple. After all, everything has a before. Before sunrise comes the night. Before your first memory came infancy. Before today came yesterday. Before every page in a book comes another page. Our minds are built to arrange experiences like stepping stones across a river. One event leads to another. One moment follows the last. Every cause has an effect, and every effect eventually becomes another cause. It's how you've learned to understand the world. If someone tells you a story, you naturally want to know how it started. If someone finishes a sentence halfway through, you instinctively ask what came first. The word before feels so familiar that you almost never stop to think about it. But sometimes the simplest words hide the deepest mysteries. Because what if before isn't just another word? What if it's something that depends on the universe existing in the first place? Imagine picking up your favorite novel. You open it somewhere near the middle and begin reading. The story unfolds page after page. Characters meet. Years pass. Entire lives are lived. Eventually you reach the final page. Now imagine asking a strange question. What happened one page after the last page? At first you might imagine another chapter. Maybe an epilogue. Perhaps a sequel. But if the book truly ends there, there isn't another page waiting. The question itself begins to lose its meaning. Not because you're missing information. Not because the final page is hidden. But because the next page simply doesn't exist inside that book. Now imagine asking an even stranger question. What happened one page before page one? Again, your mind wants to invent an answer. Maybe there was a preface. Maybe another chapter. But suppose page one really is the first page. There isn't an earlier page hiding somewhere. The idea of before page one belongs to a direction that simply isn't part of the book. In some ways, modern cosmology suggests that time itself may work surprisingly like this. For most of human history, people imagine time as something endless. A great river flowing forever into the past and forever into the future. Long before mountains existed, time was flowing. Long after every star had burned away, time would continue flowing. The universe simply floated inside that endless river. It seemed obvious. After all, rivers keep flowing whether boats are on them or not. Why should time be any different? But during the last century, physics began whispering something unexpected. Perhaps time is not the river. Perhaps the river itself had a beginning. Imagine standing beside an empty canvas. Nothing has been painted yet. No mountains. No oceans. No sky. You wouldn't ask whether the blue paint is hiding behind the mountain. The mountain hasn't been painted yet. Neither has the sky. Those ideas only make sense once the painting exists. In a surprisingly similar way, physicists began wondering whether time itself might not be the stage on which the universe appears. Instead, perhaps time is part of the universe. Not outside it. Not surrounding it. But woven into it. That possibility changes everything. Because if time is part of the universe, then asking what happened before the universe might be a little like asking what lies north of the North Pole. It's a wonderfully imaginative question. But the farther you think about it, the stranger it becomes. When explorers travel north, every step takes them closer to the pole. Eventually they arrive. Now suppose they try taking one more step north. Which direction would they walk? There isn't one. They can walk south, west, but not farther north. The direction itself has reached its limit. The question doesn't have an answer because the direction no longer exists. Some physicists believe before the Big Bang might be remarkably similar. Not because they're hiding the answer. Not because science refuses to look. But because before may stop being a meaningful direction once you reach the beginning of time itself. It's an idea that feels almost impossible to picture. After all, you've never experienced anything outside time. Every heartbeat, every breath, every conversation, every dream. Even the quiet moments between thoughts unfold one after another. Your entire existence is stitched together by moments. Trying to imagine reality without time is a little like asking a fish to imagine life without water. The fish has never known anything else. Water isn't simply where it lives. It's the medium through which every experience is possible. Time may be the same for us. It's so completely woven into your life that imagining its absence feels almost impossible. Even now, as you listen, your mind is moving gently from one sentence to the next. One idea replaces another. Seconds quietly pass. Outside, somewhere beyond your room, the Earth continues turning beneath the night sky at nearly 1,600 kilometers an hour along the equator. It spins so smoothly that you never notice. At the same time, our planet circles the Sun at over 100,000 kilometers every hour. The Sun itself orbits the center of the Milky Way. The galaxy drifts through space. Clusters of galaxies drift farther apart as the universe expands. Everything is moving. Everything is changing. Everything exists within time. So when you hear the phrase "before space existed," your mind instinctively imagines rewinding the universe like a film. Galaxies move closer together. Stars disappear. Atoms unravel. Light fades. Everything shrinks toward a single beginning. And then, surely there must be one more frame. One more moment. One final scene before it all began. But what if there isn't? What if the film doesn't begin after another scene has been cut away? What if frame one is simply frame one? This idea can feel surprisingly unsettling at first. Our minds dislike unfinished stories. We naturally search for earlier causes, earlier explanations, earlier beginnings. Children ask where birds come from. Parents explain eggs. Then children ask where eggs come from. Eventually they ask where everything came from. And sooner or later, nearly every child asks the question we're exploring tonight. What came before the beginning? It's a beautiful question. One worth asking. Not because it necessarily has an answer, but because asking it has helped humanity uncover some of the deepest truths we've ever discovered about the universe. And as we'll soon see, it was this simple word, before, that led scientists to completely rethink the nature of space, time, and reality itself. If you've ever watched an old film being played in reverse, you'll know how natural it feels. A shattered glass rises effortlessly from the floor, each tiny fragment finding its place until the glass is whole again. A campfire slowly pulls its smoke back into glowing logs. Footprints disappear from the sand as if they had never been there. Even though you know the film is simply running backward, your mind has no trouble imagining time reversing. Now imagine doing the same thing with the entire universe. Picture every galaxy slowly drifting back toward one another. The vast spaces between them become smaller with every passing moment. Giant stars that have burned for billions of years begin gathering their light back into themselves. Planets retrace their endless journeys around their stars. Clouds of gas collapse instead of expanding. Eventually, even the atoms that make up everything around you begin drawing closer together. You continue watching this impossible film in reverse. The universe grows smaller, hotter, denser. The distances between everything continue shrinking until, at least according to our current understanding of physics, you arrive at an unimaginably tiny, unimaginably energetic early universe. This is often the picture people have in mind when they think about the Big Bang. They imagine pressing the rewind button until they reach the very first frame. And then comes the question almost everyone asks: what happened one frame earlier? It sounds like the most reasonable question imaginable. After all, every movie has a previous frame. Every journey has another step behind it. Every road you've ever walked stretches back in the direction you came from. But the universe may not behave like a movie at all. The image of rewinding the cosmos is useful for helping us picture the expansion of the universe, but it can also quietly mislead us. A movie already exists before you press play. Every frame has been recorded in advance. Whether you're watching it forward or backward, the entire reel is already there. The universe is different. According to our best scientific understanding, time itself may not be something that exists independently of the universe. It may not be a giant clock ticking somewhere outside reality. Instead, time appears to be woven into the fabric of the cosmos itself, inseparable from space, matter, energy, and gravity. That idea is surprisingly difficult to grasp because every experience you've ever had has taken place inside time. You have never stepped outside it. You cannot pause it, hold it in your hands, or look at it from the outside. You simply move through it, moment after moment, without ever noticing how extraordinary that really is. Imagine trying to explain the concept of water to a fish. The fish swims through it every second of its life. Water surrounds it completely. It has never experienced anything else. Asking the fish to imagine a world without water would be almost impossible because water is not just part of its environment. It is the environment. Perhaps time is something like that for us. From the moment you were born, every heartbeat, every sunrise, every conversation, every memory, every dream has unfolded within the gentle current of time. It feels so familiar that you rarely stop to question it. Yet physics suggests that time may not be an eternal backdrop stretching infinitely in both directions. Instead, it may be something that belongs to our universe in the same way that oceans belong to Earth. If Earth had never formed, there would be no oceans to sail across. Likewise, if the universe had never existed, perhaps there would have been no time through which anything could happen. This is where the question begins to change shape. Instead of asking, what happened before the Big Bang? Scientists sometimes ask a different question altogether. They ask whether the word before is even meaningful in that context. It's a subtle difference, but an important one. Think about the North Pole again. If someone asked you to travel farther north than the North Pole, you might spend a few moments trying to picture the journey. Perhaps you imagine climbing over the pole somehow. But eventually you realize the problem isn't your imagination. The problem is the question itself. North is a direction defined by the surface of the Earth. Once you've reached the northernmost point, the direction simply stops existing. Every step from that point leads south. In exactly the same way, some physicists believe that if time truly began with the Big Bang, then before simply isn't a direction you can travel. It's not hidden behind a curtain waiting to be discovered. It isn't a secret chapter that scientists haven't found yet. It may simply be a direction that has no meaning. This idea can feel strangely unsatisfying at first. Human beings are storytellers by nature. We like beginnings that have earlier beginnings. We like explanations that reach farther back. Whenever someone gives us an answer, we're tempted to ask one more question. And before that? And before that? It's one of the reasons children can keep asking why, almost endlessly. Every answer naturally invites another question. Every explanation seems to point toward an even deeper explanation waiting just beyond it. So when someone says the universe began with the Big Bang, it's almost impossible not to ask what caused it. What switched it on? What existed beforehand? Who or what started everything? These are profound questions, and scientists continue exploring them today. But it's important to realize that not every question has an answer in the way we expect. Sometimes a question reveals more about the way our minds work than about the universe itself. Your brain evolved to understand forests, rivers, changing seasons, familiar faces, and the passing of days. It did not evolve to intuitively understand the first fractions of a second after the birth of the cosmos. The fact that these ideas feel strange isn't a sign that you're failing to understand them. It's a reminder that you're thinking about something far beyond everyday human experience. And perhaps that's part of what makes cosmology so beautiful. It gently invites you to stand at the edge of everything you've ever known and quietly admit that reality may be stranger than common sense allows. For thousands of years, people assumed space and time were permanent. They seemed obvious, almost invisible in their familiarity. Space was simply where things existed. Time was simply what clocks measured. Neither seemed particularly mysterious. Then, in the early 20th century, one remarkable idea began to reshape that picture forever. Scientists discovered that space and time are not separate after all. They are deeply connected, almost like two threads woven into the same fabric. Change one and you change the other. That realization would eventually lead physicists to an astonishing conclusion. If space can have a beginning, perhaps time can as well. And if time itself has a beginning, then the mystery we're exploring tonight becomes even deeper. Because maybe the greatest challenge isn't discovering what came before space. Maybe it's learning that the universe doesn't always have to obey the questions our minds are most comfortable asking. In the next part of our journey, we'll gently explore how one scientist's revolutionary way of looking at reality completely transformed our understanding of space and time, and why the universe may be far stranger and far more beautiful than anyone had ever imagined. For a long time, people imagined the Big Bang as the greatest explosion that had ever happened. It seems like the most natural way to picture it. You imagine a tiny point suspended in an endless black emptiness. Then, suddenly, it explodes. Matter flies outward in every direction, racing through space like fireworks spreading across the night sky. It's a dramatic image and one that appears in countless illustrations and films. But strangely enough, it isn't quite right. If you could somehow witness the earliest moments of our universe, you wouldn't see an explosion happening inside space. You wouldn't be floating safely at a distance, watching a brilliant flash expand away from you. There would be no edge to stand beyond. No empty darkness surrounding it. No cosmic room waiting to be filled. Instead, something far stranger would be taking place. Space itself would be coming into existence. That single idea is easy to say, yet remarkably difficult to picture. Every experience you've ever had has happened somewhere. Whether you're standing in a quiet bedroom, walking through a forest, sitting beside the ocean, or looking up at the stars, there has always been a place around you. Space feels so obvious that it almost disappears from your awareness. But what if space wasn't simply there? What if it had a beginning? Imagine drawing a circle on a completely blank sheet of paper. As the pencil moves, the circle appears. Before you drew it, there wasn't a hidden circle waiting beneath the page. The circle didn't emerge from another location. It simply came into existence as part of the drawing itself. Now imagine the paper didn't exist either. The pencil, the ink, even the idea of distance between 2 points. It's difficult because every analogy eventually breaks down. They all depend on space already existing, while the universe may have begun before there was any space at all. This is one of the greatest challenges in cosmology. Language itself begins to struggle. Words like outside, inside, beyond, before, and where all quietly assume that space already exists. We use them every day without thinking. Yet when we ask how the universe began, those familiar words start losing their usual meaning. Perhaps the best way to approach the mystery isn't by trying to force yourself to imagine something impossible. Instead, imagine watching the universe grow from within. Picture yourself drifting in complete darkness. Not frightening darkness, but a peaceful kind of silence. There are no stars yet. No galaxies. No planets. Not even empty space stretching endlessly in every direction. There is simply no distance to measure, no horizon to look toward, no up or down to orient yourself. Then, gently, reality begins to unfold. Not as an explosion. Not as a burst of matter flying through an already existing void. Instead, the very fabric of space begins expanding. Every tiny region grows larger. Every point becomes farther away from every other point, not because the points are racing across a cosmic stage, but because the stage itself is quietly growing. A helpful analogy is to imagine a loaf of raisin bread rising in the oven. Before the dough begins to rise, all of the raisins sit relatively close together. As the bread expands, every raisin slowly moves farther away from every other raisin. If you happen to be living on one of those raisins, you would look around and notice something remarkable. Every other raisin would appear to be moving away from you. Not because your raisin occupies the center of the loaf. And not because all the other raisins are fleeing from you. They're moving apart because the dough itself is expanding. Our universe behaves in a surprisingly similar way. Every galaxy sees distant galaxies moving away. An observer inside the Andromeda galaxy would notice much the same thing. So would an observer inside a galaxy billions of light years away. There is no special center where the Big Bang occurred. Every location sees the universe expanding around it. At first, that sounds impossible. How can everything move away from everything else? But remember, it isn't the galaxies doing all the moving. It's the space between them that slowly stretches. Imagine drawing tiny dots across the surface of a balloon. As you gently inflate it, each dot drifts farther away from the others. None of the dots sits at the center of the expansion because the expansion is happening across the surface itself. Again, the analogy isn't perfect. A balloon expands into the air around it, while our universe doesn't necessarily expand into anything at all. Even so, it helps illustrate an important idea. Expansion doesn't always require an external space waiting outside. The universe isn't expanding into a larger room. The universe is creating larger distances within itself. That distinction may seem subtle, but it's one of the most beautiful ideas in modern cosmology. It means that asking, "What is the universe expanding into?" may be a little like asking what lies east of the eastern horizon. The question quietly assumes something that may not exist. The horizon isn't a wall with another landscape beyond it. It's simply a limit created by perspective. Likewise, the universe may not require an outside. It may simply be all there is. If that's true, then space isn't like a container holding galaxies. Instead, galaxies are embedded within space itself. As space stretches, the distances between them naturally grow larger. You can actually observe this happening. Nearly a century ago, astronomers began carefully measuring the light arriving from distant galaxies. They noticed something extraordinary. The farther away a galaxy appeared, the faster it seemed to be moving away from us. At first, this seemed almost unbelievable. But observation after observation confirmed the same pattern. The universe wasn't static. It wasn't frozen in place. It was expanding. Imagine standing in a quiet field just after sunset. Around you, thousands of fireflies begin drifting slowly apart in every direction. The farther away a firefly is, the faster it seems to recede into the darkness. You might reasonably conclude that the space between you is growing. In a sense, that's exactly what astronomers discovered, except instead of fireflies, they were observing entire galaxies containing hundreds of billions of stars each. That discovery completely transformed our understanding of the cosmos. Because if the universe is expanding today, then running the story backward leads to an unavoidable conclusion. Long ago, everything must have been much closer together. Not necessarily compressed into an infinitely tiny point as older explanations sometimes suggested, but certainly packed into an extraordinarily hot, dense, energetic state unlike anything we experience today. As the universe expanded, it also cooled. Much like a cup of hot tea gradually loses heat as it sits on a table, the early universe slowly became less energetic. That cooling allowed particles to form, then atoms, then stars, then galaxies, and eventually planets like the one you're resting on tonight. It's remarkable to realize that every atom in your body has been part of this story from almost the very beginning. The calcium in your bones, the oxygen you breathe, the carbon that makes life possible. All of it traces its history back through countless generations of stars to a universe that was once unimaginably hot and astonishingly small. And yet, despite everything we've learned, one mystery still quietly remains. If space itself began expanding, what started that expansion? Was it inevitable? Was there a deeper cause? Or are we once again asking a question that only makes sense from inside the universe we already know? We'll drift a little closer to those questions next as we explore the astonishing first moments after the Big Bang, when the universe expanded faster than almost anyone would think possible. If the story of the universe ended there, it would already be extraordinary. Space began expanding, the universe gradually cooled, and over billions of years the stars, galaxies, planets, and eventually life itself emerged from that slow cosmic unfolding. But as scientists continued studying the universe, they discovered something that didn't quite fit. The universe looked almost too perfect. No matter which direction astronomers pointed their telescopes, the cosmos appeared remarkably uniform. Galaxies certainly formed clusters and stars gathered into vast spiral arms, but on the largest scales imaginable, the universe looked surprisingly smooth. Even more puzzling, the oldest light in the universe, the faint afterglow of the Big Bang itself, had almost exactly the same temperature everywhere scientists looked. At first, this might not sound particularly strange. After all, if you heat a pot of soup and stir it well, it eventually reaches roughly the same temperature throughout. Every spoonful becomes nearly identical to the next. But the early universe didn't seem to have enough time to stir itself. Imagine standing at opposite ends of an enormous desert. You and a friend are separated by thousands of kilometers. Without phones, radios, or any way to communicate, you both decide to flip a coin at exactly the same moment. Astonishingly, every single flip matches perfectly, heads, tails, for thousands of flips in a row. You would immediately suspect that something unusual was happening. The early universe presented scientists with a similar mystery. Regions of space that should never have had the opportunity to exchange information somehow appeared almost perfectly coordinated. They behaved as though they had once been in close contact, even though, according to the simplest version of the Big Bang, they shouldn't have been. For years, this puzzle remained one of cosmology's greatest mysteries. Then, in the early 1980s, physicists proposed an astonishing idea. Perhaps the universe experienced an incredibly brief moment of expansion unlike anything that has happened since. Not just fast, unimaginably fast. This idea became known as cosmic inflation. Despite the dramatic name, inflation wasn't an explosion. It wasn't matter being blasted outward through empty space. Instead, it was space itself expanding at an almost incomprehensible rate. To appreciate just how extraordinary this was, imagine placing two tiny dots only a fraction of a millimeter apart. Now imagine that, in far less than the blink of an eye, the distance between them grows until it is larger than our entire observable universe. It sounds impossible. And yet, according to the theory of inflation, something astonishingly similar may have happened. The entire event lasted only a tiny fraction of a second, far shorter than anything you could ever consciously experience. In fact, the period of inflation is thought to have lasted roughly 1/10 trillionth of a second, a number so unimaginably small that ordinary intuition simply gives up trying to picture it. It's almost as if the universe took a single breath, an impossibly deep breath. And during that breath, space itself stretched by an unimaginable amount. One of the remarkable consequences of this idea is that it helps explain why the universe appears so smooth today. Imagine looking at a small balloon before it's inflated. With your finger, you draw a tiny smiley face on its surface. At first, the drawing is only a few centimeters across. But as you begin inflating the balloon, the smiley face grows larger and larger. Eventually, if the balloon became enormous, the tiny curved line of the smile would begin looking almost perfectly straight. The curve hasn't disappeared. It has simply become so large that, from your limited perspective, it appears flat. Something similar may have happened to the universe itself. Before inflation, the entire observable universe may have occupied an incredibly tiny region where everything could easily interact. Temperatures could become nearly uniform. Tiny quantum fluctuations could spread evenly throughout this small region. Then inflation stretched that tiny patch to an extraordinary size. The smoothness remained, but now it covered distances of billions of light years. It's one of those ideas that sounds almost magical when you first hear it. Yet it arises from careful attempts to explain observations that astronomers can actually measure. Even the tiny imperfections in the ancient light left behind by the Big Bang seem to match the patterns inflation predicts. Those slight irregularities eventually became the seeds from which every galaxy, every star, every planet, and ultimately every living creature would form. In a sense, every structure in the universe began as an almost unimaginably small ripple. That's a remarkable thought. Everything you have ever known, the oceans, mountains, forests, cities, birdsong on a spring morning, the person you were as a child, and the person quietly listening tonight, can trace its history back to tiny fluctuations in the earliest moments of cosmic history. It's difficult to imagine a grander family tree. And yet, even inflation leaves important questions unanswered. Why did inflation begin? Why did it stop? What exactly caused space to expand so dramatically? Scientists continue searching for those answers. Some theories suggest inflation was driven by a special field that briefly filled the young universe with enormous energy. Others propose ideas connected to quantum gravity, where our current understanding of physics begins to break down. The truth is, we don't yet know. One of the most beautiful things about science is its willingness to say exactly that. Not every mystery has been solved. Some remain invitations rather than conclusions. As you drift through these ideas tonight, it's worth remembering that the Big Bang was never intended to explain everything. Despite what the name sometimes suggests, it isn't a theory about the absolute beginning of existence. It is a theory describing how our universe evolved from an incredibly hot, dense early state into the vast cosmos we observe today. It tells us an extraordinary amount. It explains why galaxies are moving apart, why ancient light still fills the universe, why the chemical elements exist in the proportions we measure, why the cosmos has changed over billions of years. But there comes a point where our equations begin to lose their certainty. As we approach the very first instant, closer and closer to what we call time zero, gravity, quantum physics, and our current mathematical descriptions no longer fit together perfectly. It's a little like following a beautifully drawn map until, quite suddenly, the paper ends. Beyond that edge, we simply don't know what the landscape looks like. Perhaps future discoveries will extend the map farther. Perhaps they will reveal that the map itself needs to be redrawn. Or perhaps we'll discover that the question we've been asking was never quite the right one to begin with. That uncertainty isn't a weakness. It's part of what makes cosmology such a fascinating journey. Every answer opens the door to another mystery, and every mystery reminds us how much more there is still to explore. As you picture the universe gently expanding around you, it's comforting to remember that the very space surrounding you right now is part of that same expansion. The room around you, the distant stars beyond your window, the galaxy slowly turning through the darkness. They all share a common origin in a universe that has been unfolding for nearly 14 billion years. You are not simply observing that story. You are living inside it. And in the next chapter, we'll move even deeper into one of its strangest ideas of all. If space could have a beginning, what does that tell us about time itself? Are they truly separate things, or are they two sides of the same extraordinary fabric that makes our universe possible? It's easy to think of space and time as two completely different things. Space feels like the stage where everything happens. It's the distance between your home and the nearest city, the emptiness between the Earth and the Moon, the vast ocean stretching between one galaxy and another. Time, on the other hand, feels like something entirely separate. It's the quiet ticking of a clock, the changing of the seasons, the slow passing of birthdays and memories. For most of human history, this seemed perfectly reasonable. If you asked someone living hundreds of years ago what space was, they might simply point around them. And if you asked what time was, they might point to the rising sun, the changing shadows, or the movement of the stars across the night sky. Space was where things existed. Time was what kept moving. Simple, separate, independent. Even some of history's greatest thinkers imagined the universe this way. Isaac Newton, whose ideas shaped physics for centuries, described time as something absolute. Whether anything happened or not, time would continue flowing. It was like an invisible river stretching endlessly into the past and endlessly into the future. The universe simply floated within it. It was an elegant picture. Comforting even. You could imagine removing every planet, every star, every cloud of gas from the universe, and there would still be empty space waiting to be filled. Remove every clock, every person, every heartbeat, and time would continue passing all the same. For more than 200 years, that picture worked remarkably well. It explained falling apples, orbiting planets, the motion of the moon, even the paths of comets that wouldn't return for generations. But then, at the beginning of the 20th century, a quiet revolution began. Its ideas weren't shouted across crowded lecture halls or announced with dramatic certainty. Instead, they slowly emerged from careful mathematics and an uncomfortable realization that something about the universe didn't quite add up. At the center of that revolution was a young patent clerk named Albert Einstein. At the time, Einstein wasn't the famous scientist whose face now appears in history books. He spent his days reviewing inventions submitted to the Swiss Patent Office. Yet during his spare moments, he liked to imagine impossible journeys. He asked questions that sounded almost childlike. What would happen if you could ride alongside a beam of light? What would you see? Would the light appear frozen beside you? Or would something stranger happen? These simple thought experiments eventually led him to one of the most profound discoveries in the history of science. Space and time are not separate. They are deeply connected. Imagine a large piece of fabric stretched tightly across a frame. From a distance, it looks perfectly flat. If you gently pull on one corner, the entire sheet changes shape. Move another corner and the rest of the fabric responds as well. Now imagine that this fabric isn't made of cotton or silk. Instead, it's woven from both space and time together. Physicists call this spacetime. It's one word because, according to Einstein, these two things cannot truly be separated. They form a single structure that underlies everything in the universe. This idea is difficult to appreciate because your everyday experience hides it remarkably well. As you lie comfortably listening tonight, the room around you seems completely still. The floor beneath you feels solid. Time appears to pass at exactly the same pace from one moment to the next. Nothing feels unusual. Yet reality is behaving in ways that are far stranger than your senses reveal. Imagine climbing aboard a spacecraft capable of traveling unimaginably close to the speed of light. As your journey begins, everything inside the spacecraft seems perfectly normal. Your heartbeat feels the same. Your breathing remains steady. A cup of tea cools exactly as you would expect. From your perspective, nothing has changed. But to someone watching from Earth, something extraordinary is happening. Time aboard your spacecraft is slowing down. Not because your clock is broken. Not because you're imagining it. Time itself is unfolding differently. This sounds almost impossible, yet it has been confirmed countless times through experiments. Tiny atomic clocks flown aboard airplanes return showing ever so slightly different times than identical clocks left on the ground. Satellites orbiting Earth experience time differently from people standing on its surface, and engineers must account for those tiny differences every single day. Without doing so, modern GPS systems would quickly become inaccurate, and the maps on your phone would begin drifting farther from your true location. It's remarkable to realize that one of the strangest ideas in physics quietly helps you navigate through everyday life. Time, it turns out, isn't universal. It isn't perfectly identical everywhere. It depends on how you move, and it depends on gravity. Imagine standing at the bottom of a deep valley while a friend stands high on a nearby mountain. Neither of you would notice anything unusual. Your conversations would feel normal. Your watches would seem perfectly accurate. Yet, incredibly, time would be passing ever so slightly faster for your friend standing higher above Earth's surface. The difference is tiny, far too small for human senses to detect. But it's real. Gravity changes the flow of time. The stronger gravity becomes, the more slowly time passes. This isn't merely a clever idea or a mathematical trick. Nature itself behaves this way. If you drifted close to a black hole, where gravity becomes unimaginably powerful, the effect would become dramatic. Minutes for you might correspond to years for someone watching safely from far away. While you calmly experienced a short journey, entire generations could pass elsewhere in the universe. It's one of those ideas that almost feels like science fiction. Yet it's a direct consequence of Einstein's understanding of spacetime. The universe doesn't treat time as a separate cosmic clock ticking identically for everyone. Instead, time bends. It stretches. It flows differently depending on where you are and how you move. The more scientists explored these ideas, the clearer something astonishing became. If gravity can change time, and if motion can change time, then time isn't a fixed background at all. It's part of the universe itself. This realization quietly transforms the question we've been asking since the beginning of tonight's journey. Because if time belongs to the universe, if it bends, stretches, and changes along with space, then perhaps asking what happened before the universe existed is rather like asking what happened before the existence of time itself. It's a subtle shift in perspective, but an enormously important one. The universe may not have appeared inside an already existing timeline. Instead, the timeline itself may have begun alongside the universe. Imagine opening a brand new notebook. The first page is blank until you begin writing. The story starts with the very first sentence. It wouldn't make much sense to ask what was written on page 0 if the notebook was manufactured with page 1 as its beginning. Likewise, if spacetime itself came into existence during the earliest moments of the Big Bang, there may simply be no earlier page waiting behind it. That doesn't mean the universe is fully understood. Far from it. It simply reminds us that the deepest mysteries often require us to rethink the questions themselves. Sometimes the universe doesn't give unexpected answers. Sometimes it asks us to ask better questions. And in the next part of our journey, we'll gently follow that idea even further, exploring what philosophers and physicists have long debated about the true nature of time, and whether the past, present, and future might exist in ways far stranger than our everyday experience suggests. Before you continue, take a slow breath and notice something you almost never think about. This very moment. It feels obvious, doesn't it? There is the past, where your memories live. There is the future, filled with possibilities that haven't happened yet. And in between the two is the present, a single moving moment that seems to glide steadily forward, carrying you with it. It feels so natural that it's difficult to imagine reality working any other way. But what if this experience of time is only part of the story? Imagine standing beside a wide, peaceful river. The water flows gently past you without ever stopping. Leaves drift by one after another, disappearing around a bend in the distance. You instinctively think of time in much the same way. The future slowly arrives, becomes the present for the briefest instant, and then quietly slips away into the past. This image has comforted people for centuries. It matches your everyday experience perfectly. You remember yesterday but not tomorrow. You can influence what comes next but not what has already happened. The river seems to flow in only one direction. Yet the deeper physicists explored the universe, the less certain they became that this flowing river was fundamental to reality itself. According to Einstein's theory of spacetime, every event has a location not only in space but also in time. In a sense, the universe can be described as a vast four-dimensional landscape, where every moment has its own place, just as every mountain, ocean, or distant galaxy has its own location in space. Imagine opening an enormous atlas. Instead of showing countries or continents, every page contains a different moment in time. One page shows the birth of the first stars. Another shows dinosaurs wandering ancient forests. Another contains the moment you first learned to ride a bicycle. Another shows you listening quietly tonight. Each moment occupies its own page. None of the pages are moving. The book simply exists. Some physicists and philosophers have wondered whether reality itself might be something like this. Rather than time flowing, perhaps every moment simply exists as part of a greater whole. This idea is often called the block universe. It's one of the strangest concepts modern physics has inspired. In the block universe, the past isn't gone. The future isn't waiting to be created. Instead, every moment exists within the structure of spacetime, much like every location already exists on a map. Your experience of moving through time would then be similar to reading a novel. When you read a book, page 1 doesn't disappear after you turn to page 2. The final chapter already exists, even though you haven't reached it yet. The story feels as though it unfolds one page at a time because that's how you experience it, not because the later pages are being written as you read. Whether this picture truly reflects reality is still debated. Many physicists find it useful. Others believe something important is still missing. And perhaps that's one of the most fascinating aspects of science. Even when our equations become incredibly successful, they don't always tell us exactly what reality is. They tell us how reality behaves. Understanding what that behavior truly means is often a much deeper question. As you listen tonight, it's comforting to remember that uncertainty isn't a flaw in our understanding. It's often where the most interesting discoveries begin. Centuries ago, people believed the Earth stood perfectly still while the sun revolved around it. That picture seemed obvious because it matched everyday experience. Then astronomy revealed something far stranger. Likewise, time feels as though it flows because that's how human consciousness experiences it. But nature may not be obligated to match our intuition. Imagine looking at a single frame from a movie. Nothing moves. The actors remain frozen. The scenery never changes. Now imagine placing thousands of those frames together in exactly the right order. As the projector begins playing, movement suddenly appears. Characters laugh, rivers flow, stars explode, entire civilizations rise and fall. The motion wasn't contained inside any individual frame. It emerged from the relationship between them. Some philosophers have wondered whether consciousness might experience time in a somewhat similar way. Perhaps your awareness travels through the moments of space-time, creating the sensation of a flowing present, much like a projector bringing still images to life. No one knows for certain. But simply considering the possibility reminds us how mysterious consciousness and time both remain. There's another question quietly waiting beneath all of this. Why does time seem to move only forward? Why do broken cups never leap back onto tables? Why does smoke drift upward from a candle instead of gathering neatly back into the flame? Why do people grow older rather than younger? The laws of physics themselves are surprisingly symmetrical. Many of them work almost equally well whether time runs forward or backward. Yet the universe we experience has a very clear direction. Physicists call this the arrow of time. One of the leading explanations comes from a concept known as entropy. Without becoming lost in complicated mathematics, entropy is simply a measure of how many different ways something can be arranged. Ordered systems naturally become less ordered over time. A neat stack of papers gradually becomes messy. A drop of cream swirls into coffee until the two become impossible to separate again. Ice melts into water. Sandcastles slowly crumble beneath wind and waves. Nature tends to move from order toward greater disorder. That gradual increase gives time its apparent direction. Imagine dropping a deck of perfectly ordered playing cards onto the floor. They scatter in every direction. If you watched a recording of the cards spontaneously jumping back into a perfectly arranged deck, you would immediately know the film was playing backward. Your intuition about time comes largely from this increase in disorder. It's one of the reasons memories point toward the past rather than the future. The universe has a direction in which complexity unfolds, stars evolve, and lives are lived. Curiously, this raises another mystery. If entropy always increases, then the early universe must have begun in an astonishingly ordered state. Why did reality begin in such a remarkably low entropy condition? Once again, science has compelling ideas but no complete answer. It seems that every time we solve one mystery, another quietly appears just beyond it. And perhaps that's exactly what makes the universe such a peaceful thing to contemplate. No matter how much humanity learns, there always seems to be another horizon waiting in the distance. Another question just beyond the last. Another layer beneath the one we've just uncovered. As you lie here tonight, it's comforting to remember that you don't need to solve any of these mysteries. You don't need to choose between competing theories or understand every equation that physicists spend decades developing. Simply wondering is enough. The universe has been patiently unfolding for nearly 14 billion years. It isn't in a hurry to reveal every secret tonight. For now, you can simply rest with the questions themselves. What is time really? Did it truly begin alongside space? Could there ever have been a reality without either of them? Or are these questions gently leading us toward an entirely different way of understanding existence? Those are the mysteries we'll begin exploring next, as we leave behind what we know about spacetime and drift into the remarkable possibilities scientists have proposed for what, if anything, may have come before our universe. So far tonight, you've traveled to the edge of one of science's greatest mysteries. You've seen why asking what came before space is not as straightforward as it first appears. You've explored how space itself may have begun expanding, and how time might have come into existence alongside it. If that picture is correct, then the universe didn't simply appear inside an already existing stage. The stage itself may have been born with the performance. But for many scientists, that naturally leads to another question. If the Big Bang marks the beginning of our universe, does it also mark the beginning of everything? Or could our universe be just one chapter in a much larger story? The honest answer is that we don't know. What follows is where science begins to move away from well-established observations and into the realm of carefully constructed possibilities. These ideas are not guesses made without evidence, nor are they proven facts. They are attempts to extend our understanding into a place where our current theories can no longer guide us with certainty. In other words, we've reached the shoreline of what we know. Beyond it lies an ocean that has not yet been fully explored. Imagine standing on a quiet beach just before sunrise. The sea stretches endlessly toward the horizon. You can see only a small part of it, while most of it disappears beyond your view. The fact that you cannot see the rest of the ocean doesn't mean it isn't there. It simply means your perspective has limits. Science often feels much the same. With every new discovery, humanity's horizon moves a little farther away. Yet each time it does, we discover that the unknown is even larger than we imagined. One of the first ideas we'll explore begins with something that sounds almost impossible. Imagine that empty space isn't truly empty. At first, that seems like a contradiction. Empty means nothing is there. How can nothing contain anything? But in modern physics, the vacuum of space is far stranger than everyday intuition suggests. Imagine walking into an enormous concert hall after everyone has gone home. The lights are off. The seats are empty. The musicians have packed away their instruments. From a distance, the room appears completely silent. Yet if you stand perfectly still, you might notice tiny sounds you hadn't heard before. The quiet hum of the ventilation system. The soft creak of the building settling. The distant vibration of traffic somewhere beyond the walls. The room isn't truly silent. It only appears that way. Physicists believe empty space behaves in a surprisingly similar fashion. Even when every particle has been removed, something remains. According to quantum mechanics, what we call empty space is filled with tiny fluctuations. Fields that permeate the universe continue to possess a small amount of energy, even in their lowest possible state. This is known as the quantum vacuum. The word vacuum sounds peaceful and still, but at unimaginably small scales it is anything but motionless. Imagine looking at the surface of a calm lake from an airplane. From high above, the water appears perfectly smooth. But if you slowly descend toward the surface, you begin noticing tiny ripples. Come closer still, and countless little waves dance across the water. The closer you look, the less empty it seems. Something similar happens when physicists mathematically examine the vacuum itself. At incredibly small scales, nature becomes restless. Tiny fluctuations constantly appear and disappear. Particle-antiparticle pairs seem to briefly emerge before vanishing again so quickly that the universe barely notices. This doesn't violate the laws of physics. Instead, it's one of the peculiar consequences of quantum theory, a framework that has been tested with extraordinary precision for more than a century. It's important not to picture these particles as tiny marbles popping into existence inside ordinary empty space. Reality at quantum scales doesn't behave like familiar everyday objects. Instead, it's better to imagine a gentle sea of possibilities, constantly shifting in ways that our everyday intuition struggles to visualize. Now imagine something extraordinary. What if our entire universe somehow emerged from one of these quantum fluctuations? This idea has fascinated physicists for decades. If the quantum vacuum already contains energy and obeys the laws of quantum mechanics, perhaps under very special circumstances it could give rise to an expanding universe. Notice how different this is from saying the universe came from absolutely nothing. In everyday conversation, the word nothing usually means the complete absence of everything. No matter. No energy. No space. No time. No laws of physics. The quantum vacuum is not that kind of nothing. It already possesses structure. It already follows mathematical rules. It already contains quantum fields. In fact, many physicists would hesitate to call it nothing at all. This distinction is important because it's often misunderstood. You may occasionally hear someone say that science has shown the universe came from nothing. But that's usually an oversimplification of a much more subtle idea. Science has not demonstrated that absolute nothingness spontaneously produced everything. Rather, some theories explore whether our universe could emerge naturally from a quantum state that is very different from the ordinary idea of empty space. It's a fascinating possibility, but it remains exactly that, a possibility. No experiment has yet confirmed that this is how our universe began. And that brings us to one of the quiet strengths of science. Scientists are comfortable saying, "We don't know." That sentence may not make headlines as often as bold claims, but it's one of the reasons science continues making progress. Every unanswered question becomes an invitation to keep exploring. Imagine assembling a gigantic jigsaw puzzle without ever having seen the finished picture. At first, you connect only a handful of pieces. Slowly, landscapes begin appearing. Colors form patterns. Edges become clearer. Yet there are still large empty spaces where pieces remain missing. You wouldn't claim to know exactly what belongs there. Instead, you would examine the surrounding pieces and carefully consider which shapes might fit. That's essentially what cosmologists do. The observations we already have, the expansion of the universe, the cosmic microwave background, the distribution of galaxies, the behavior of gravity, all provide pieces of the puzzle. Theories about what happened before the Big Bang attempt to connect those pieces in ways that remain mathematically consistent with everything we've already observed. Some ideas will eventually prove incorrect. Others may survive decades of testing. Perhaps one will eventually become part of our accepted understanding of reality. Or perhaps the correct answer hasn't even been imagined yet. There's something wonderfully humbling about that thought. Humanity has been asking where everything came from for thousands of years, yet we may still be standing near the very beginning of the journey toward understanding. As you quietly imagine these possibilities, notice how different this feels from ordinary questions in everyday life. Usually, when you ask where something came from, you expect a simple answer. A tree grows from a seed. A river begins in the mountains. A house is built by people. The origin of the universe may not be so straightforward. Its beginning may require ideas that challenge the very way human beings naturally think. And that's perfectly all right. You don't need to force yourself to picture every quantum fluctuation or every mathematical possibility. Simply allowing yourself to wonder is enough. Because the deeper you travel into cosmology, the more you discover that certainty becomes increasingly rare, while curiosity becomes increasingly valuable. In the next part of our journey, we'll explore another remarkable possibility. What if the Big Bang wasn't truly the beginning at all? What if our universe has been through countless cycles of birth, expansion, collapse, and rebirth, repeating over unimaginable stretches of cosmic time? Now imagine something very different. Instead of thinking about the universe as a story with a single beginning, imagine it as a rhythm. Like the gentle rise and fall of the ocean, or the steady beating of a heart, perhaps the cosmos itself moves through endless cycles. A beginning is followed by an ending, which quietly becomes another beginning over and over again. It's an idea that has fascinated people for thousands of years. Many ancient cultures imagined the universe this way long before modern science existed. To them, creation wasn't a one-time event. The cosmos was alive, constantly renewing itself through endless cycles of birth, change, destruction, and rebirth. Surprisingly, some modern physicists have explored remarkably similar ideas. One possibility is known as the cyclic universe. According to this hypothesis, the Big Bang may not have been the absolute beginning of everything. Instead, it could have been the latest chapter in an unimaginably long sequence of universes. Imagine watching the seasons change. Spring slowly gives way to summer. Summer fades into autumn. Autumn becomes winter. At first glance, winter might seem like the end of the story. The trees stand bare, flowers disappear beneath the cold ground, and the landscape grows quiet. But winter isn't truly an ending. Without anyone noticing the exact moment it happens, spring quietly returns. New leaves appear, birds begin singing again, and life continues its familiar rhythm. Perhaps, some scientists have wondered, the universe behaves in a somewhat similar way. Instead of a single beginning followed by a single ending, perhaps cosmic history stretches through countless cycles, each giving rise to the next. One version of this idea is called the Big Bounce. To understand it, imagine throwing a rubber ball toward the floor. The ball falls faster and faster until, for a brief instant, it becomes compressed. Then it rebounds, rising upward once again. Now replace the ball with the universe itself. Instead of expanding forever, imagine that gravity eventually slows the expansion. Galaxies stop drifting apart. Over unimaginable stretches of time, everything begins moving closer together again. The universe grows hotter and denser until it reaches an extreme state. But instead of collapsing into a final ending, perhaps it bounces, beginning a new era of expansion. The Big Bang in this picture wouldn't be the first moment of existence. It would be the moment of the bounce. A transition rather than a beginning. It's an elegant idea because it naturally replaces the question, what came before? With a different answer. There was another universe before ours, and perhaps another before that, stretching back through cycles so vast that ordinary numbers lose their meaning. Yet, like many beautiful ideas, it comes with challenges. Current observations suggest that the universe's expansion is not slowing down. In fact, it appears to be accelerating. Galaxies are moving apart faster and faster as time passes, a discovery that surprised astronomers when it was first announced in the late 20th century. Something, which scientists currently call dark energy, seems to be pushing the universe apart on the largest scales. Dark energy remains one of the greatest mysteries in modern cosmology. Despite its name, it isn't necessarily a substance floating through space. It's simply the label scientists give to whatever is causing this unexpected acceleration. Imagine watching a ball roll up a hill. You naturally expect it to slow down, stop, and eventually roll back toward you. Instead, the ball somehow begins climbing faster and faster all by itself. You would immediately realize that something important is missing from your understanding of the situation. That's rather similar to how astronomers felt when they discovered the accelerating expansion of the universe. Something fundamental was happening. Something our existing picture couldn't fully explain. Whether dark energy will continue forever remains unknown. If it does, then the universe may keep expanding indefinitely, becoming colder, darker, and emptier over unimaginable spans of time. But if its behavior changes in the distant future, other possibilities remain open. And that's one of the reasons cosmologists continue exploring ideas like the Big Bounce. Another remarkable proposal goes even further. Imagine that our universe is only one tiny bubble floating within an unimaginably larger cosmic ocean. This is the idea behind eternal inflation. Earlier, we explored cosmic inflation, the incredibly rapid expansion thought to have taken place during the universe's earliest moments. But some physicists have suggested that inflation may never have completely ended. Instead, it may continue in regions far beyond everything we can observe. Imagine a pot of water gently beginning to boil. Tiny bubbles constantly appear throughout the water. Each bubble forms, grows, and drifts away while new bubbles continue appearing elsewhere. Now imagine each bubble is an entire universe. Every bubble has its own expanding space, its own history, and perhaps even its own laws of physics. Our universe would simply be one bubble among countless others. The space between these bubbles wouldn't resemble ordinary empty space. It would belong to a much larger structure that we currently have no direct way of observing. It's a breathtaking idea. Not because it has been proven. It hasn't. But because it reminds us how limited our observable universe may actually be. Everything you've ever seen, the Milky Way, every distant galaxy captured by powerful telescopes, every quasar, every nebula, every black hole, could represent only a tiny region within something vastly larger. Imagine standing on a beach and picking up a single grain of sand. Now imagine discovering that every grain on every beach on Earth is itself an entire universe. The scale quickly becomes impossible to picture. Of course, ideas like eternal inflation naturally lead to another fascinating possibility. If countless universes exist, could some of them be different from ours? Perhaps one contains stronger gravity, another weaker gravity. Perhaps some never form stars. Others might collapse almost instantly after they begin. Some may never produce the chemistry required for life. And somewhere, if the number of universes is truly enormous, there could even be universes that resemble our own in astonishing ways. This broad collection of possibilities is often referred to as the multiverse. It's one of the most famous, and sometimes misunderstood, ideas in modern cosmology. It's important to remember that the multiverse is not an established scientific fact. There is currently no direct observational evidence confirming that other universes exist. Rather, the multiverse emerges naturally from several mathematical theories that successfully describe other aspects of physics. Whether those implications reflect reality remains one of the biggest unanswered questions in science. Perhaps future discoveries will reveal ways to test these ideas. Perhaps they will point us in an entirely different direction. For now, these possibilities remain exactly what they are: thoughtful, carefully developed hypotheses built upon our current understanding, but still waiting for stronger evidence. And perhaps that's the perfect place to pause for a moment. As you lie quietly tonight, it's remarkable to realize how far your imagination has traveled. Only a short while ago we were asking what came before space itself. Now you've wandered through quantum fluctuations, bouncing universes, eternal inflation, and the possibility of countless cosmic bubbles drifting beyond the limits of everything we can ever observe. Whether any of these ideas ultimately prove correct isn't the most important part of tonight's journey. What's truly extraordinary is that human beings, tiny creatures living on a small planet orbiting an ordinary star, have learned enough about the universe to even ask these questions. The cosmos remains wonderfully mysterious, and perhaps it always will. In our next chapter, we'll leave behind modern physics for a little while and travel thousands of years into the past, discovering how ancient civilizations wrestled with exactly the same question. Long before telescopes, satellites, or equations, people looked into the night sky and wondered what existed before everything began. Their answers were very different from today's scientific theories, yet their curiosity was exactly the same as ours. Long before there were telescopes powerful enough to peer into distant galaxies, before anyone had heard the words Big Bang or quantum physics, and thousands of years before mathematics could describe the expansion of the universe, people were already asking exactly the same question that has guided our journey tonight. Where did everything come from? It's remarkable to think about. Imagine standing beneath the night sky tens of thousands of years ago. There are no cities glowing on the horizon, no airplanes crossing overhead, no satellites silently orbiting the Earth. There is only darkness, broken by an astonishing number of stars. The Milky Way stretches from one horizon to the other like a pale river of light, so bright that it casts a faint glow across the landscape. You don't know what stars are. You don't know that the Earth is a planet. You don't know that those tiny points of light are unimaginably distant suns, each with their own story. All you know is that every evening the heavens awaken above you. The stars appear. The moon changes shape. The seasons slowly pass. Children grow into adults. Forests change. Rivers continue flowing. Life unfolds in rhythms that seem both familiar and mysterious. Sooner or later, someone asks the question, how did all of this begin? It's easy to imagine that this curiosity belongs to scientists, but curiosity is much older than science. In fact, it may be one of the oldest human qualities of all. Long before there were laboratories, people searched for patterns. They watched the sun rise each morning. They noticed that winter always gave way to spring. They learned when animals migrated and when fruits ripened. Understanding these patterns meant survival, but it also inspired wonder. As people became better observers of nature, they also became storytellers. Stories helped explain what could not yet be measured. They connected generations. They gave shape to mysteries that seemed far too large for ordinary language. Today, we often separate mythology from science, but thousands of years ago there was no such distinction. Both were sincere attempts to understand reality. Both began with careful observation of the world. The difference lay in the tools available. Modern scientists used telescopes, satellites, particle accelerators, and mathematics. Ancient civilizations used imagination, memory, symbolism, and the stars themselves. Their conclusions were different. Their curiosity was exactly the same. Imagine sitting beside a small fire on a cool evening in ancient Greece. Above you, the stars slowly wheel across the sky. Someone asks where the universe came from, and an elder begins telling a story that has been passed down through countless generations. According to one of the oldest Greek traditions, everything began with chaos. Today, the word chaos often makes us think of confusion or disorder. But to the ancient Greeks, chaos wasn't simply a mess of random things. It was more like a vast emptiness, a great yawning gap from which everything else eventually emerged. From chaos came earth, the sky, the sea, and the many forces that would shape the world. It's fascinating how familiar that idea feels. Even though modern cosmology tells a very different story, both begin with the recognition that the universe we see today once existed in a profoundly different state. Neither picture begins with stars already shining in the heavens. Both begin with simplicity before complexity. As Greek philosophers continued thinking about the universe, some gradually shifted away from mythology and toward ideas that sound surprisingly modern. One philosopher named Anaximander proposed that everything came from something he called the apeiron, often translated as the boundless or the infinite. It wasn't a god in the traditional sense. Instead, it was an eternal, undefined reality from which all things emerged and to which they would eventually return. Imagine trying to describe the ocean without ever having seen water. You might struggle to find the right words. Perhaps that's why so many ancient thinkers described the beginning using ideas like the infinite, the endless, or the unknowable. They recognized that whatever existed before the world could not easily be compared to anything familiar. Centuries later, another Greek philosopher named Aristotle suggested something even more surprising. Perhaps the universe had no beginning at all. To Aristotle, the cosmos was eternal. It had always existed and always would. The stars moved through endless cycles, and time stretched infinitely in both directions. For nearly 2,000 years, this idea shaped much of Western thinking about the universe. It's remarkable how different this is from the modern picture suggested by the Big Bang. Today, many physicists believe time itself may have begun roughly 13.8 billion years ago. Aristotle imagined time with no beginning whatsoever. Two completely different conclusions. Yet both emerged from careful attempts to understand the same mysterious sky. Now let your imagination drift much farther east. Picture yourself standing beside a quiet river in ancient India as the first light of dawn begins touching the horizon. Mist rises gently from the water. Birds awaken in distant trees. Around you, generations of thinkers have spent centuries reflecting on existence itself. In Hindu philosophy, the universe is often described not as something created once, but as something that endlessly cycles through creation, preservation, and dissolution. Entire universes are born. They endure for unimaginable spans of time. Eventually they dissolve. Then, after another immense interval, new universes arise once again. These cycles are measured not in years or even millions of years, but in cosmic timescales so vast that ordinary numbers begin losing their meaning. One complete cycle is said to last billions of years, a surprisingly immense duration considering these ideas were developed thousands of years before modern astronomy could estimate the age of the Earth itself. Of course, these numbers were not derived through scientific observation in the way cosmologists work today. They emerged through philosophy, spirituality, and symbolic reflection. Yet it's fascinating to notice the shared intuition. Both modern cosmology and ancient Hindu thought imagine a universe whose history unfolds across incomprehensibly vast stretches of time. Perhaps that's no coincidence. Whenever human beings look deeply enough into the night sky, the same realization quietly appears. The universe is far older, far larger, and far stranger than ordinary life suggests. Whether through myth, philosophy, or science, people have always found themselves humbled by its immense scale. And perhaps that's one of the few ideas that every civilization has quietly shared. No matter where people lived or what language they spoke, looking upward inspired the same feeling: wonder. The stars asked questions before humanity had words to answer them. And in the next part of our journey, we'll continue traveling across the ancient world, exploring how civilizations in Egypt, Scandinavia, and Buddhist traditions each imagined the mysterious beginning of everything, and why their stories still reveal something profound about the way human beings search for meaning beneath the endless night sky. As the centuries passed, people living in different parts of the world continued looking up at the same sky, yet they imagined its beginning in beautifully different ways. Mountains, deserts, forests, and rivers shaped the stories they told, but beneath those differences lay the same quiet curiosity. How did reality begin? Why is there something instead of nothing? And what, if anything, came before? Now imagine yourself standing along the banks of the Nile River more than 4,000 years ago. The air is warm and the first light of morning spreads across the water. The river has sustained life here for countless generations. Every year it floods, leaving behind rich soil that allows crops to grow once again. To the ancient Egyptians, creation itself often resembled this familiar rhythm. One of their oldest creation stories begins with an endless, dark ocean known as Nun. Before the world existed, there was no land, no sky, no sun, and no people. There was only an infinite expanse of still, silent water. Then, from those waters, the very first mound of land slowly emerged, much like dry ground appearing after a flood begins to recede. Upon that first piece of land stood the Creator, bringing order where there had once been only endless possibility. Whether taken literally or symbolically, it's a peaceful image. Creation doesn't begin with violence or chaos. It begins quietly. Land rises. Light appears. The world slowly becomes a place where life can exist. Thousands of years later, modern cosmology would describe a very different process, yet there's something surprisingly familiar about the feeling. Both stories begin with simplicity before complexity. Both imagine a universe gradually unfolding rather than appearing fully formed in an instant. Now let your imagination travel north, where the winters grow colder and the nights much longer. Picture vast forests stretching across the landscape, mountains disappearing into mist, and icy winds moving across open valleys. Here, among the ancient Norse peoples, another remarkable story took shape. According to Norse mythology, before the world existed there was a great emptiness called Ginnungagap. The name itself carries a sense of mystery. It is often translated as the yawning void, a great open gap that existed before the familiar world came into being. On one side lay a realm of intense cold and ice. On the other burned a realm of fire and heat. Where those two extremes eventually met, something entirely new emerged. From their meeting came the first living being, and over time the rest of the world slowly followed. It's fascinating how often ancient cultures imagine creation emerging from opposites coming together. Light and darkness, order and disorder, fire and ice, stillness and movement. These stories weren't attempting to describe particle physics or cosmology in the modern scientific sense. Instead, they reflected something deeply human, the observation that new things often emerge when different forces interact. Even today, science frequently describes nature through relationships rather than isolated objects. Stars form when gravity pulls together clouds of gas. Planets emerge from swirling disks of dust. Galaxies grow through countless interactions over billions of years. The language is different. The methods are entirely different. Yet both mythology and science recognize that the universe is shaped by processes rather than remaining forever unchanged. Now imagine traveling farther east once again, this time to ancient Buddhist traditions. Interestingly, Buddhism approaches the question of beginnings in a way that feels surprisingly different from many other traditions. Rather than focusing on a single moment of creation, many Buddhist teachings suggest that searching for an absolute beginning may not even be the most useful question. Instead, existence is often described as an ongoing process without a clearly identifiable first moment. Worlds arise, endure for vast periods of time, dissolve, and then new worlds eventually appear. The cycle continues without requiring a single, ultimate starting point. If that sounds strangely familiar, it's because some modern cosmological ideas explore similar possibilities. As we discussed earlier, certain scientific models propose that our universe may be one phase in an ongoing sequence of cosmic events. Of course, the similarities should not be overstated. Buddhism developed through philosophical and spiritual reflection, while cosmology relies on observation, mathematics, and experimental evidence. They arrive at their ideas through entirely different paths. Yet it's still remarkable to notice how often thoughtful people, separated by thousands of years and vast distances, found themselves questioning whether the universe truly required a single beginning. Perhaps that tells us something about the way human curiosity naturally unfolds. Whenever we encounter a mystery, we instinctively look for what came before it. And when we reach what appears to be the beginning, we almost can't help asking whether there might be something beyond even that. It's a habit so deeply rooted in human thinking that it has appeared in cultures across nearly every continent. Imagine gathering all of these ancient thinkers together beneath the same night sky. A Greek philosopher, an Egyptian priest, a Hindu sage, a Norse storyteller, a Buddhist monk. Each would describe the origin of the universe differently. Each would use different symbols, different language, and different ideas. Yet if you listen carefully, you might notice that none of them were really trying to answer different questions. They were all responding to the same feeling. The feeling that arises when you look into the darkness above and realize the universe is far larger than your own life. The feeling that whispers there must be a story behind everything you see. In many ways, that feeling still exists today. Our telescopes have become unimaginably powerful. We can observe galaxies billions of light years away. We can detect faint radiation left behind shortly after the Big Bang. We can simulate the evolution of the cosmos using supercomputers capable of performing trillions of calculations every second. And yet, after all of those discoveries, we still find ourselves asking one of humanity's oldest questions. How did everything begin? The tools have changed. The mathematics has changed. The language has changed. But the curiosity remains almost exactly the same. There's something quietly comforting about that. It reminds you that wondering about the universe isn't reserved for physicists or astronomers. It isn't limited to people with advanced degrees or giant observatories. Wonder belongs to everyone. It belonged to the first people who ever looked upward. It belongs to scientists working late into the night today. And it belongs to you, quietly listening as the stars continue shining above a world that is still trying to understand them. Perhaps that's one of the greatest lessons history offers us. Every generation believes it stands close to the answers. Then time gently reveals an even larger mystery waiting beyond. The ancient stories weren't failures because they differ from modern science. They were stepping stones in humanity's long journey toward understanding. They remind us that knowledge grows gradually, one question leading to another, each generation adding another small piece to an impossibly large puzzle. And maybe that puzzle will never be completely finished. Maybe the universe is simply too vast, too subtle, and too beautiful to ever fit entirely inside the human mind. Rather than making the cosmos feel distant, that thought can make you feel connected to something timeless. For thousands upon thousands of years, countless people have paused beneath the same sky, asked the same questions, and felt the same mixture of curiosity and humility. Tonight, you've joined that conversation. And as our journey continues, we'll return to the present day once more, leaving behind the stories of ancient civilizations and gently exploring one final, extraordinary question. What if, before space, before time, before even the earliest quantum fluctuations, there was simply nothing at all? Of all the questions we've explored tonight, perhaps this one is the most difficult to truly imagine. What if, before space existed, there was simply nothing? At first, the idea seems almost peaceful. You close your eyes and picture complete darkness. No stars shine in the distance. No galaxies slowly drift through space. No planets circle their suns. No light travels across the cosmos. There is only an endless black emptiness stretching in every direction. But then, very gently, you realize something surprising. That isn't nothing. Even in your imagination, you've created a vast, dark space. It may be empty of objects, but it still has distance. It still has direction. It still has an up and a down, a left and a right. It still stretches endlessly before you. You've imagined an empty universe. Not the absence of a universe. It's a subtle difference, yet one of the most important distinctions in all of philosophy and cosmology. Human beings are extraordinarily good at imagining things. You can picture an endless ocean, a distant galaxy, or a mountain taller than any you've ever seen. You can imagine dragons, impossible machines, and worlds with purple skies. But trying to imagine absolute nothingness is different. Every image your mind creates already contains something. Perhaps there is darkness. Perhaps there is silence. Perhaps there is empty space. But darkness is still something you can experience. Silence is still the absence of sound within time. Empty space is still space. Absolute nothingness is something else entirely. Imagine opening a brand new notebook. Every page is completely blank. There are no words, no drawings, no colors. At first glance it seems empty. Yet the notebook itself still exists. The paper exists. The pages exist. The blankness exists. Now imagine trying to remove the notebook itself. Not just the pages. Not just the cover. Everything. No paper. No empty pages. No place where writing could ever appear. No object that could even be called a notebook. That is much closer to what philosophers mean when they speak about absolute nothing. Not an empty container. No container at all. This is where language begins to feel strangely uncomfortable. Almost every sentence you can form assumes that something exists. Even saying, "there was nothing," quietly suggests that nothing was somehow there, waiting like an invisible object. But if absolute nothing truly existed, there wouldn't even be a place where nothing could exist. There would be no there. There would be no before. There would be no passage of time during which nothing patiently waited. The more carefully you think about it, the more slippery the idea becomes. It's like trying to hold water in your hands. Every time you believe you've grasped it, it quietly slips away. Perhaps that's because your brain was never designed to imagine non-existence. From the moment you were born, you've experienced a universe filled with things. Faces, sounds, colors, gravity, air, light. Even when you close your eyes in a perfectly quiet room, your heartbeat continues. Your breathing continues. Time continues moving forward. You have never experienced the complete absence of reality. Neither has anyone else. Imagine asking someone to describe a color that has never existed. Not a color they've forgotten. Not a mixture of familiar colors. An entirely new color that no human eye has ever perceived. It's almost impossible. Your imagination only has familiar building blocks available. The same is true when you try imagining absolute nothingness. Your mind instinctively reaches for darkness because darkness is familiar, or silence because silence is familiar, or empty space because you've seen empty rooms and open skies. But none of those are truly nothing. They're all forms of something. This realization has fascinated philosophers for thousands of years. One of the earliest thinkers to wrestle with the idea was the ancient Greek philosopher Parmenides, who lived more than 2,000 years ago. His conclusion was surprisingly bold. He argued that absolute nothingness cannot exist. His reasoning was elegantly simple. To think about nothing is already to think about something. To speak about nothing is already to give it a kind of existence within language. Therefore, he suggested non-existence is impossible. Whether or not you agree with his conclusion, it's remarkable how modern the question still feels. Even today, philosophers continue debating whether nothing is actually a meaningful concept. Some argue that nothingness is logically impossible. Others believe it remains a genuine possibility that simply lies beyond ordinary human intuition. Science approaches the question differently. Rather than beginning with logic alone, physicists ask what observations can tell us about reality. And here, something unexpected happens. As we've already explored, what scientists call the vacuum of space is not truly empty. Even after removing every particle that can be removed, tiny quantum fields remain. Energy remains. The laws of physics remain. Fluctuations continue appearing and disappearing at unimaginably small scales. To a physicist, the vacuum is astonishingly active. To a philosopher searching for absolute nothingness, however, the vacuum is still something. In fact, it's an incredibly complicated something. This distinction often creates confusion. Imagine walking into an empty theater after a performance has ended. The audience has left. The actors have gone home. The stage is quiet. You might naturally say the theater is empty. But it isn't truly empty. The seats remain. The walls remain. The lights remain. The building itself remains. Likewise, when physicists describe empty space, they aren't talking about the absence of everything. They're describing a universe in its lowest energy state. That's a profoundly different idea. It's one of the reasons scientists are usually very careful with the word nothing. Everyday language and scientific language sometimes use the same words while meaning very different things. As you lie quietly tonight, it's worth appreciating just how extraordinary that is. One tiny word. Nothing. A word children learn almost as soon as they begin speaking. Yet behind that simple word lies one of the deepest puzzles humanity has ever encountered. Can absolute nothing actually exist? Or is existence somehow more fundamental than non-existence itself? Perhaps there was never a state of perfect nothingness. Perhaps reality in one form or another has always existed. Or perhaps the human mind simply isn't equipped to imagine what true nothingness would actually be. None of these possibilities are easy to picture. And that's perfectly all right. Some mysteries aren't meant to be rushed. They're meant to be explored slowly, allowing each idea to settle before moving gently to the next. Because sometimes the greatest discoveries don't come from finding quick answers. Sometimes they begin by realizing that the question itself is far stranger than you first imagined. In the next part of our journey, we'll continue exploring this remarkable mystery, asking whether absolute nothing could ever give rise to something, and why many physicists believe that the laws of nature themselves may hold the key to one of the oldest questions humanity has ever asked. As you continue lying comfortably, allow that question to remain in your mind for just a little longer. Could absolute nothingness ever become something? At first, your intuition probably says no. If there is truly nothing, then nothing can happen. There is no space for change to occur. No time for events to unfold. No energy to transform. No particles to collide. No laws of nature to guide what comes next. Nothing, by its very definition, seems incapable of doing anything at all. And yet, this simple conclusion quietly leads to another fascinating question. Why is there something instead? The philosopher Gottfried Wilhelm Leibniz asked this question more than 300 years ago, and it has never really gone away. In fact, many people consider it to be the deepest question in all of philosophy. Why is there something rather than nothing? It's such a short sentence. Only a handful of ordinary words. Yet hidden inside it is a mystery that reaches beyond galaxies, beyond time, and perhaps even beyond the limits of science itself. Imagine walking into a library that stretches farther than you can see. Every shelf is filled with books describing stars, planets, black holes, atoms, gravity, chemistry, biology, and the countless details that make up the universe. Together, those books explain an extraordinary amount about how reality behaves. But then you notice one book missing. The book explaining why the library exists at all. In many ways, that's where modern science finds itself today. We understand an astonishing amount about how the universe evolves. We know that galaxies form from clouds of gas pulled together by gravity. We know that stars forge the heavier elements inside their blazing cores. We know that planets gradually emerge from swirling disks of dust surrounding young stars. The story of the universe after its earliest moments has become increasingly clear. But when we ask why there is a universe in the first place, the answers become much less certain. Some physicists have proposed that perhaps existence doesn't require a cause in the way our everyday experiences do. That idea may sound surprising. After all, every event in your daily life seems to have a reason. A window breaks because a ball strikes it. Rain falls because water vapor condenses in the atmosphere. A tree grows because a tiny seed slowly develops over many years. Cause leads to effect, again and again. It's one of the most reliable patterns you know. But notice something interesting. Every example of cause and effect you've ever experienced has taken place inside the universe. Every cause has unfolded within time. Every effect has followed afterward. If time itself began with the universe, then asking what caused the beginning may be very different from asking what caused a tree to grow or a star to explode. Cause and effect may themselves depend on time existing. Imagine reading the very first sentence of a novel. You wouldn't ask which sentence came immediately before it inside the story. The first sentence marks the beginning of the narrative. Anything before that belongs to the author, not to the story itself. Some physicists suggest that the Big Bang may be similar. The familiar chain of causes and effects could begin there, rather than extending endlessly beyond it. If that's true, then searching for an earlier cause may simply be applying everyday reasoning in a place where everyday reasoning no longer works. It's a difficult idea to accept because human intuition has been shaped by ordinary experience. You have never encountered an event that wasn't preceded by another event. Your entire life has unfolded as a sequence of moments. Naturally, your mind expects the universe itself to follow the same pattern. Yet reality has surprised humanity before. There was a time when people believed the earth stood motionless at the center of creation. Certainly felt that way. The ground beneath their feet seemed perfectly still. Later, we discovered that our planet spins through space while orbiting the sun at astonishing speed. Our intuition was understandable. It simply wasn't the complete picture. Perhaps the same is true when it comes to beginnings. Another remarkable possibility sometimes discussed by physicists is that the laws of nature themselves may be fundamental. Instead of asking where the laws of physics came from, perhaps they are simply part of reality in the deepest possible sense. Imagine asking why the number 2 exists. You could write the symbol on paper. You could count 2 stones. You could hold 2 apples. But the concept of 2 doesn't seem to require someone to invent it. It appears to be a basic feature of mathematics itself. Some philosophers have wondered whether the laws of physics might resemble mathematical truths in this way. Not created, not manufactured, simply fundamental. Of course, this idea immediately invites another question. Why these laws instead of different ones? And once again, certainty quietly slips away. The deeper we travel into these mysteries, the more we find ourselves standing at the boundary between science and philosophy. Neither discipline has all the answers. Both continue asking careful questions. And perhaps that's exactly as it should be. Imagine climbing a mountain before sunrise. As you reach the summit, you expect to see everything clearly. Instead, the first light reveals another mountain beyond the one you've just climbed. And beyond that, another. Each new horizon expands your view, but it also reveals how much farther there is still to travel. Knowledge often grows this way. Every answer opens another question. Every discovery uncovers another mystery waiting quietly beyond it. Rather than making the universe feel frustrating, many scientists find this deeply inspiring. It means reality is richer than any single explanation. It means there is always more to learn, more to wonder about, more to discover. As you listen tonight, it's comforting to remember that you don't need to reach a final conclusion. You don't need to decide whether the universe emerged from a quantum fluctuation, whether reality has always existed, whether there are countless universes beyond our own, or whether absolute nothingness is even possible. Simply allowing these ideas to drift gently through your imagination is enough. After all, the universe itself doesn't seem to rush. Galaxies take hundreds of millions of years to complete a single rotation. Stars are born over immense stretches of time and shine quietly for billions of years before their lives finally come to an end. Even the light from the nearest large galaxy has spent more than 2 million years traveling through space before reaching your eyes. The cosmos has always moved with extraordinary patience. Perhaps we can borrow a little of that patience tonight. Perhaps not every mystery needs to be solved before we find peace with it. In fact, there is something strangely comforting about accepting that some questions may always remain just beyond the horizon. They remind us that the universe is not a finished story. It is still unfolding. New telescopes continue looking deeper into space than ever before. New observatories listen for faint ripples in spacetime itself. New generations of scientists continue asking questions that would have sounded impossible only a few decades ago. The story isn't over. It's still being written. And in a quiet way, so are you. Every moment you spend wondering about the universe becomes part of humanity's long conversation with the stars, a conversation that has lasted for thousands of years and will almost certainly continue for thousands more. As our journey draws closer to its end, we'll leave behind equations, philosophies, and competing theories, and simply reflect on what these mysteries mean. Because perhaps the greatest gift the universe offers isn't a collection of perfect answers. Perhaps it's the invitation to keep wondering, even as the stars slowly drift across the endless night above. As our journey through the universe begins to slow, you may notice something curious. The question that brought you here tonight may not feel quite the same anymore. At the beginning of our journey, it seemed wonderfully simple. What was there before space itself existed? It sounded like a question waiting patiently for an answer. Perhaps there was another universe. Perhaps there was a quantum vacuum. Perhaps there was an endless cycle of creation and rebirth. Or perhaps there was simply nothing at all. But after wandering through the landscapes of cosmology, philosophy, and ancient imagination, you may have discovered that the question itself has quietly changed. It has become less about finding one final answer, and more about learning how to ask it. Sometimes the universe doesn't become simpler the closer you look. Sometimes it becomes more mysterious. And strangely enough, that mystery doesn't have to be frustrating. It can be comforting. Imagine standing beside the ocean late at night. The waves arrive one after another with perfect patience. They don't hurry toward the shore and they don't pause to explain themselves. They simply continue their ancient rhythm just as they have for millions of years. You don't feel the need to count every wave. You don't wonder where each individual ripple began. You simply listen. The sound itself becomes enough. Perhaps the universe can be experienced in much the same way. For most of human history, people believed that understanding meant eliminating mystery. Every unanswered question seemed like an empty space waiting to be filled. Every unknown fact appeared to be another problem waiting for a solution. Science has certainly answered many extraordinary questions. It has revealed that the Earth circles the Sun rather than the other way around. It has shown that stars are not tiny lights attached to a distant ceiling, but immense suns scattered across incomprehensible distances. It has taught us that galaxies drift apart as space itself expands, and that the atoms making up your body were forged long ago inside ancient stars. Each discovery has brought remarkable clarity. Yet every answer has also revealed another layer of mystery waiting quietly beneath it. Discovering galaxies led us to wonder how galaxies formed. Understanding stars led us to ask where the elements came from. Learning about the Big Bang led us to ask what happened before it. Every horizon we reach reveals another horizon beyond. Perhaps that's not a flaw in our understanding. Perhaps that's simply what reality is like. Imagine hiking through a range of gentle mountains just before dawn. As you reach the top of one hill, another appears in the distance. Beyond that lies another, softened by morning mist. Then another, fading almost completely into the horizon. No single hill contains the entire landscape. Yet each one offers a slightly broader view than the last. Human knowledge grows in much the same way. Every generation climbs a little higher. Every generation sees a little farther. But no generation reaches the final summit. And maybe that's exactly what makes exploration so meaningful. If every mystery disappeared tomorrow, if every equation were solved and every question answered, something precious might quietly disappear as well. Wonder. That gentle feeling that first inspired ancient people to look upward. The same feeling that encouraged sailors to navigate by the stars. The same feeling that led philosophers to ask impossible questions. The same feeling that inspired scientists to build telescopes capable of seeing nearly to the beginning of time itself. Wonder has always been one of humanity's greatest companions. Not because it gives us certainty, but because it gently reminds us that the universe is always larger than we imagine. Think about your own place within that universe for a moment. You're living on a small rocky planet orbiting an ordinary yellow star. That star is one among hundreds of billions inside the Milky Way. Our galaxy is only one among perhaps hundreds of billions more spread across the observable universe. And even the observable universe may be only a tiny part of a much greater reality. When you first hear numbers like these, it's easy to feel incredibly small. But perhaps there's another way of looking at it. Rather than making you insignificant, the universe has made it possible for something extraordinary to happen. After nearly 14 billion years of cosmic history, tiny collections of atoms learned to ask where they came from. Those collections of atoms became living cells, then forests, then oceans filled with life, then creatures capable of curiosity. Eventually, one small species learned to gaze upward and quietly ask questions about the stars. In a very real sense, the universe has become aware of itself through beings like you. That thought has always carried a quiet beauty. The same atoms that were once scattered through ancient stars are now capable of imagination. The same physical laws that shaped galaxies have also shaped minds capable of wondering about galaxies. You are not separate from the story of the cosmos. You are one small chapter within it. Perhaps that's why these questions feel so personal. When you ask where the universe came from, you're also asking where you came from. When you wonder whether time had a beginning, you're wondering about the very framework that has carried every moment of your own life. The search has never really been about distant galaxies alone. It's also been about understanding ourselves. As you continue resting comfortably, imagine floating once again through the quiet darkness of space. The stars surround you in every direction. Not crowded together, but gently scattered across unimaginable distances. Some are only a few years old. Others have already lived and died before Earth itself was born. Light from distant galaxies continues traveling patiently across billions of years, carrying silent stories that no human civilization has witnessed from beginning to end. There is no hurry here. The universe has never rushed. Stars take millions of years to form. Galaxies slowly dance around one another over hundreds of millions of years. Black holes quietly wait through spans of time so immense they almost defy imagination. Against that peaceful backdrop, perhaps it's alright that some questions remain unanswered tonight. Perhaps certainty isn't what brought you here. Perhaps it was curiosity. And curiosity, unlike certainty, never really comes to an end. It simply keeps inviting you to look a little farther, a little deeper, a little more gently. In the final part of our journey, we'll allow those questions to slowly drift into the background, leaving behind only the quiet feeling of being part of a universe that remains endlessly mysterious, endlessly beautiful, and wonderfully at peace with its own unanswered questions. For now, there is nothing left to solve. The universe has shared many of its stories tonight, but it has also kept many of its secrets. Somehow that feels appropriate. A cosmos with no mysteries would be a quieter place, but perhaps not a more beautiful one. Imagine drifting gently through the darkness one final time. There is no destination ahead of you. No finish line waiting in the distance. Only an endless expanse filled with silent stars, each one shining with a light that began its journey long before anyone alive today had taken their first breath. Some of that light has traveled for millions of years. Some for billions. Patiently crossing the universe without ever hurrying. Without ever asking to be understood. As you float peacefully through this vast ocean of space, you begin to notice something. The silence no longer feels empty. Feels full. Full of possibility. Full of questions that don't demand immediate answers. Full of stories that humanity has only just begun to uncover. For thousands of years, people have looked upward and wondered what existed before everything began. They imagined endless oceans, eternal cycles, boundless voids, gods, mathematics, quantum fields, and universes beyond imagination. Each generation brought its own ideas. Each generation moved the story forward just a little. And now, without even realizing it, you've become part of that same story. Perhaps one day, centuries from now, people will understand the beginning of the universe in ways we cannot yet imagine. They may discover entirely new laws of physics, new ways of thinking about space and time, or answers that seem impossible from where we stand today. Or perhaps the mystery will remain. Perhaps the question itself will continue traveling through history, whispered beneath countless different skies by people who pause for a moment and simply wonder. Either possibility is strangely comforting, because it reminds you that knowledge is not a destination. It is a journey. A slow walk beneath an infinite sky. One question leading quietly to another. As you continue drifting, imagine the Milky Way slowly turning around you. Its hundreds of billions of stars move so gradually that the motion is almost impossible to notice. Far beyond it, countless other galaxies continue their own silent dance. Beyond them lies more darkness, more light, more mystery. The universe asks nothing of you tonight. It doesn't require you to understand every equation or remember every theory. It doesn't ask you to choose between one possibility and another. It simply invites you to look up, to wonder, to appreciate the extraordinary fact that you exist in a universe capable of producing stars, planets, oceans, life, and minds curious enough to ask where it all began. Take one more slow breath. Feel the weight of your body resting comfortably beneath you. Notice how still everything has become. The room around you is quiet. Your thoughts have slowed. The questions that once seemed so urgent now drift gently like distant constellations, present but peaceful. You don't need to chase them anymore. The universe will still be there tomorrow night. The stars will continue shining. Galaxies will continue expanding. Time will continue carrying the cosmos forward, just as it has for nearly 14 billion years. And somewhere, far beyond what anyone has ever seen, reality will continue unfolding its story, one quiet moment after another. You don't have to reach the end of that story tonight. Simply knowing that it exists is enough. So let your breathing become slower. Let your thoughts become softer. And as sleep gently begins to find you, allow yourself to drift with the same patience as the universe itself. Slowly, quietly, effortlessly. Good night. Before you drift off completely, if you enjoyed tonight's relaxing journey through the universe, I'd really appreciate it if you subscribe to the channel. There are many more peaceful explorations of space, science, and the greatest mysteries of reality waiting for you. Sleep well, and I'll see you on our next journey among the stars.